In this video, I'm going to be talking about the general solutions for getting sine, cos, and tan. Now, I'm going to start off with the easiest case, and that is to say when is tan theta equal to something. So let's choose tan theta equals 1. I mean, we know what the solution is, right? Now, if I was just taking about the simplest case, I would end up saying theta is simply equal to 45 degrees. If you're looking for the radian solution, I will do that in a bit, but let's just focus on the degrees for now. But the thing is, tan repeats every 180 degrees. Okay, so let me just draw the tan function. So it looks a bit like this, right? So tan theta, but it keeps on repeating. So that's 90, but the next one will be 270, and then 540, and so on. Okay, so these are the horizontal asymptotes. But regardless, they repeat like that, and then they repeat in each direction. But what we want is when it's tan theta equal to 1. So the first solution is when it's 45. The next solution will be sorry, so this is 90. The next one will be 9. So this position over here is 180, so it'll be 180 plus 45, which is going to be 225. Okay, so I'll just try and squeeze that in there, 225. And then the next position will be 270 plus 90, so this position is 360, and that plus 45, which should make it 405, and so on. This is actually going to go on forever. But what you'll notice is that it's always going to be 180 plus. So sorry, 180 plus a multiple of 180 plus 45 degrees, right? So the general solution for theta is going to be 180 times n plus tan inverse of whatever we had. So in this case we had 1, but just for being general, I'm just going to say a. Okay, so in our particular case, a was 1 and you had 45 degrees. Now n is an integer. It can be any integer. Okay, so it can be negative numbers as well. In fact, it should be negative numbers. So negative, I don't know, 100 all the way up to 100. But anyway, you get the point. So that's tan theta. So tan theta is the easiest one. Now let's think about cos theta. Okay, so cos theta is equal to, now I'm not going to choose 1, I'm going to choose a half. So if cos theta is equal to half, again, the simplest case, theta will be equal to 60. But again, let me draw the cos function. So the cos function will look a bit like this. Those are my axes, and drawing this function, it looks like that. So remember, it's this wave. It repeats every 360 degrees, and so this thing over here is 360. I should have probably drawn a few more. I'll draw it on this side. So it'll look like this and keeps going. Right now, what you'll notice, if I say cos theta equals a half, is that, so this point over here is a half. So if I draw a dotted line over here, so the first 60 was over there. The thing is, the minus 60 is also a solution. Now if you get to this point at 360, it's going to be 360 plus 60, which is 420, and also 360 minus 60 as well. Same thing over here. At this bump, it's going to be plus or minus 60 at these 2 points. So the general solution for theta in this case is going to be 360n plus or minus cos inverse of a. Now, if you're wondering why I haven't started off with sine, it's because sine is actually one of the harder ones. Okay, so sine. Okay, so let's try and deal with sine theta is equal to a half. Now, I'm not actually going to derive a special formulation like I did for tan and cos, because I'll show you why. So sine theta equals a half. The base case is theta is equal to 30 degrees. I'll show you with sine theta. So sine theta is actually one of the uglier ones. So if I do this, so it'll keep repeating like that, and so on. Okay, so basically sine theta equals a half. It happens around this 90 mark over here, I guess. So it's, yeah, so I really don't want to derive another one. What I'm going to do instead, I'm going to use this thing over here, the fact that cos theta is equal to half. Now, if you're wondering how can I use that over here, you need to remember that sine theta is simply, so sine theta is simply cos 90 minus theta. Okay, so this is what we're going to use. So this is the main result. So coming back to this question over here, so I will have cos of 90 minus theta is equal to a half. And using this thing over here, I can say 90 minus theta, and remember not theta, 90 minus theta is equal to 360 n plus or minus cos inverse of a half. Okay, I know that's 60 degrees, but I'll just leave it there. So therefore theta is equal to 90 minus 360 minus plus, I suppose it doesn't really matter, cos inverse of a half. Okay, so all I did was change the sine theta question into a cos question. Right, so you really don't need another special function for sine. Okay, so there you go. So there is my final result for general solution of sine. If you have any questions or comments, please let me know. Please hit subscribe, so that's very important. And thanks for watching.